All right. Accidentally muted my mic. All right. Good morning, everybody. I'm just trying to set things up here. Give me 1 second to get ready. Today we are doing my numbering topic 1E, which is applications. Well, application of quadratic functions. We've seen, oh, my program's slow today. We've seen everything we are really interested in seeing to a large degree when it comes to quadratic functions. Um, it's always nice, agree to disagree, to stop and look at some word problems, look at something that hints at something a little more practical. We aren't going to do things that are, I guess, maybe super realistic, because those things bring a lot of complexity, which we might not be ready for at this stage. But it's nice to just see what's a word problem, a more practical setting where quadratic functions may be used. Well, in problem 1.7, I have one such example. Let me see if I can zoom in here. I can zoom a little bit. Okay, so we only have this one problem, just to illustrate something you could do with quadratic functions, still hiding a lot of the difficulty and the technicalities, perhaps. We have, let me just use the first one and not talk about things in general, but let's have something specific to look at. Okay, so I'm going to do, I need to make a new page for my problem here. Whew, everything is so slow today with my computer. It's not interested in quadratic functions. Well, you have to be. No choice. Okay, so I'm going to do problem 1.7, number 1. Okay, let's just have a look at it. So I have a cost in dollars to produce X number of I'd rather be a Sasquatch t-shirts, X of them. That's given by a function, and it's just a linear function that shows as the number of t-shirts that I produce changes, the cost is going to change, and it's going to increase. The more I make, the more it costs me. Fair enough. This just says I'm not making negative t-shirts, right? I'm making 0 or more t-shirts. And then in addition to that, the price demand function in dollars per shirt is given by this. Now that means that's sort of how many I'm going to sell. If I make X, then the price at which I can sell them, assuming I sell them all for simplicity, is going to be given by this. Let's just ignore the range for X. We don't have to read too much into that right now. So assuming I sell my t-shirts, I can sell them depending on how many I produce, because I could flood the market, right? If I produce too many, that changes the demand, and the price could go down. It depends on the item. If I produce very few, then they become rare, and there could be a higher demand for them. Or the demand could, in a sense, stay the same, but people are willing to pay more because there are fewer of them. Okay, so now I want to look at how my profit changes depending on the number of t-shirts. So I'm looking for a profit function. And then I'll answer some other questions once I have that. So to keep things very simple, we have our basic relationship. Profit is going to equal, let's call it revenue minus cost, right? All the money coming in, take away all the money going out. Nice and simple. Now I am, let's say, producing and selling. Whoopsie, that's an R. Let's say here. They've defined it for me, but I'll do it again. X is representing the number of items, in this case t-shirts, that I'm producing. Whew, there's a huge delay in my pen here. That's very annoying. Producing and selling. Let's just assume those two are the same. When I'm writing and when it shows on the screen, it is not quite the same right now, which is very strange. Then I also have the price, right? Now they've defined some things for me here. I'll just define the price, which is actually a function of how many I produce, but P is going to represent the price per item. Okay, so let's look at the cost first. So here, the profit, I'm going to call it P. They defined it for me really by asking this. Big P. So let's make it like this. Let's give it a little head, fancier head, so I can see a little p and a big P of X. So X is my input. How do I calculate the profit? Well, the money that I'm going to get in minus how much it costs me, and how much it costs me is exactly given by this cost function. That'll be my C for cost, C of X. So how do I calculate how much money I'm getting from selling X number of t-shirts at P dollars per t-shirt? That's simply P times X. So little p times X, like so. Okay, so that's our basic formula, if you will, relationship between profit, revenue, cost, keeping things as simple as possible still. Is everyone happy with that equation that we're going to use? Okay, so we don't want to make things too complicated. If you've done economics and things like that, sure, things can get way more complicated. We don't want to. It's not the point. It's not the goal for us. Okay, so now let's get to the specifics in our problem. So everything's defined for me, so I can certainly skip the first step in my word problem. They've defined everything for me, so that's nice. So we're going to have our profit. Sorry, I made that a nice big P, right? Big P equals our price per item times the number of items, that's our revenue, minus the cost, which is going to depend on X. Now, this little p is also going to be a function of X. Let's put in the detail now. Little p is 30 minus 2x. 30 minus 2x. Then times x minus cost 2x plus 26. 2x plus 26. So think about profit. You're selling an item, but it's costing you something to make that item. How much money are you actually getting? The amount of your profit is how much money you get from selling it. Take away how much it cost you. That's actually what you make. So the cost is given directly. It changes depending on how many items I'm making, sure, but it's a cost. The amount of money I get in, let's suppose I sell 10 t-shirts at $5 each. How much money did I just get from those sales? 5 times 10. But now in general, I'm selling X t-shirts, and they cost little p dollars per t-shirt. It's still the product of the two. is the amount of money I'm getting in. But I have to take away my cost to see what my profit actually is. Now, once this gets specific, it might be a little bit easier. So now my X is the number of t-shirts I'm selling. The cost is going to change the more I make. The price per t-shirt is going to change the more t-shirts I make as well. It's not a constant price. If I dump hundreds of t-shirts onto the market, into the store or wherever, then people don't want to pay that much. It's not rare anymore. But if there's only a few and it's an exclusive t-shirt, people are willing to pay more. So the price changes depending on the number of items available. Okay. So we filled in all the details they give me. My question now again is this profit function correct based on the things that they give me, right? They gave me C, they gave me little p, and we understand what X is. Is that correct? How do you feel about the profit function? I'm still looking for a mistake. Where is it? Yes, you have to remember to subtract all of the cost. And the cost is 2x plus 26. If I knew, for example, I made 10 t-shirts, then I would have 20 plus 26, and that number is the cost would need to be subtracted. So I need those brackets there. Very easy to miss the brackets. Now, in order to see what kind of function am I even working with here, before I can move forward and answer the rest of their questions, let's see what this simplifies to. All right, so I'll just multiply the x in, 30x minus 2x squared minus 2x minus 26, a lot of minuses. I'm going to put them in increasing powers of x, decreasing powers of x, negative 2x squared, and then I have a plus 28x and a minus 26. And that, I'll label it again, is my profit function. Now I can look at this function and say, oh, let me move the mouse. It's a quadratic function, which means my analysis can exploit the things I know about quadratic functions. All right. So let me check out what else do they want me to do. A whole bunch of things apparently. Find the number of items which need to be sold in order to maximize the profit. Now, in the beginning, this question might not have made much sense. But now that I see, oh, it's a quadratic function, a parabola, there could be a maximum, and I want to find information about that maximum. But they knew it was going to be a quadratic function, that's why. Then I find the maximum profit, find the price that goes with that maximum profit, and we'll do the rest in a second. Okay, so now I want to forget temporarily where this comes from. There, it's gone. And I just want to analyze the properties of this quadratic function. So I go through my list. I might not need all of it, like x-intercepts and stuff I might not need. But I do want to check the leading coefficient, which is -2, which is negative, which means graphically my parabola is pointing down, which means I'm going to have a maximum, which is good because that's exactly what they want me to find. Okay. Now I know that that maximum is going to sit right in line with the axis of, whoa, that's an ugly Y. The axis of symmetry. My cat is acting weird. What's your problem? Which is, I've memorized, at -b/2a. Plug it in, I get -28 over 2 times negative 2. Oh, that's a nice number. That would be a 7. They made it so nice. 7. All right. Now let me finish the whole thing and then we'll have concluding sentences to explain in words again what this all means. I know I'm getting a maximum. My maximum function value, I don't memorize a formula for the vertex. I just plug it in. It's the profit, which is my function, evaluated at 7. Now let's give MathBot a chance. I'm lazy. It's his birthday. Who wants to do arithmetic on your birthday? So we'll give MathBot a chance to do your thing and see what the corresponding y value is. Well, p value in this case. 2 equal signs to start MathBot. Negative 2 times 7 squared, we know is 49, plus 28 times another 7, minus 26. Give me an answer, MathBot. You're my only hope. 72. All right. Let's say we're done for the moment. They don't ask me to graph it, so I mean, I totally can. Of course, I don't know exactly where the transformations are, right? This is the downside. I know that at 7 for x, this is the profit. 7, I'm going to reach a maximum here, and that maximum profit is 72. That's good enough. So, the maximum profit is, it's not a lot, but $72 when I'm only producing 7 shirts. 7 shirts are produced, sold. All right, progress, good. Now I double check what questions do they want. Find the number of items which need to be sold in order to maximize the profit. Great, we did that. Find the maximum profit. Oh, we did that as well. Find the price to charge per item in order to maximize the profit in this way. Now, how do we do that? Well, we have our price function, so to speak. Little p is 30. Oh, come on. That doesn't even look like a 3. 30 minus 2x. So the price depends on the number of t-shirts that I sell. I now know I should sell 7. So my, let's say here, corresponding, that was a G, price per item, t-shirt, is given by little p of 7. What was it? 30 minus 2x. So 30 minus 2 times 7. Let me double check. I have a terrible memory. Now I'm sure. Okay. So that would be 16. 30 minus 14 is 16. So in other words, $16 per t-shirt, as they ask. Oh, t-shirt gets a little hyphen. So we have used the profit function, realized it's a quadratic function. Well, the numbers might not be realistic, yes. Don't look too closely at the numbers. It could be, I don't know, super small t-shirt, I don't know. It's more illustrating where quadratic functions could come up. We've seen the profit function is quadratic, which means We could ask for a maximum profit if A is suitable. We then find the maximum profit and the number of items, which is really the coordinate of the vertex. And we find the price that would give me that maximum profit. Lastly, yeah, you only sold 7, you're right. Maybe the other ones have more realistic numbers. Lastly, we want to find and interpret the break-even point. Okay, so now let's suppose I have analyzed the situation before deciding to make these t-shirts so that I can decide, well, am I even going to make a profit? Is it worth it? Is the profit going to be enough for my liking? All those things. I should probably decide that first before going through all this hassle. So I've now seen that if I were to sell this based on the market analysis and the demand that there are for this t-shirt, I'm going to be able to sell 7, or I should sell 7 to give me the maximum profit. Maybe $72 is a lot for me, maybe not. I can then decide. And I should charge $16 per t-shirt and so on. Then I can decide. Right now I have all the information. Should I move forward with this based on this analysis? Yes or no? It's up to you. Another question is, what is the break-even point? Let's write that down first. Break-even point. And I use the word point loosely. That is going to be essentially when my profit, which we call big P, is 0. So that means that the revenue equals the cost, right? Revenue minus cost equals 0. That means they're the same, which means, as the name suggests, I'm breaking even. The money that I'm going to get is just enough, exactly the same as what it cost me to do all this in the first place. Any less than that, I would lose money. So at the very least, regardless of the effort that I put in, I don't want to lose any money. Okay. So let's see in this case, once I actually can open the tab. Oh, we don't have a lot of space. I want to squeeze it in. Where do we squeeze it in? It's a good, oops. It's a good question. My space is not good. I'm going to squeeze it in over here. So my break-even point is when my revenue, which is little p times x, equals my cost. Revenue equals cost, meaning profit is 0. So now I have to remember, what was the price function? 30 minus 2x. That all times x. I should make a new page, shouldn't I? Yeah. This is not going to be enough space, I don't think. What was the cost function? $2x plus 26. 2x plus 26. Maybe we can squeeze it in here. I really want to. So then this is 30x minus 2x squared equals, show the equal sign, thank you, 2x plus 26. So now I have a quadratic equation, which means group everything on one side. Which side do we want? It doesn't really matter. Negative 2x squared. I have a 30x here, minus 20, minus 2 gives me a 28x. Take the 26 over as well to give me, not minus, that's a plus, to give me a minus 26 though, equal to 0. So I have a quadratic equation to solve, which means I use the quadratic formula, which I'm going to do on a new page just so that we can see it if we want to. But you can write as little or as much detail as you want when you do the quadratic formula. Whew, my computer is not happy today. So let's see here. Now, I don't remember my function. Negative 2x, I'm going to have to write this again. Negative 2x squared plus 28x minus 26. I do remember some of it. Double check. Double check. Good. Hopefully that's right. No one is saying that they disagree, so that means they agree. So I have x equal to, by my quadratic formula, negative b plus or minus b squared, oh, that's going to be unpleasant, minus 4 times a times c over 2 times a. Now I like to just calculate what's inside the square root so that my calculation isn't too overwhelming. And my voice is breaking up. All right, so let's just ask MathBot, what is this inside the square root? So 28 squared, I mean, of course, I know that, but I'll give you a chance. Minus 4 times 2 times 26. And it is a minus. I have 3 negatives here, so it's a minus. What's inside the square root, MathBot? 576. I believe you. Okay, so then I get x is equal to, if I use the plus, negative 28 plus, oh, I can't type either, square root of 576 divided by negative 4. Let's just see if I typed that right. I didn't even put an equal sign in it. What's wrong with me? It's 1? All right. That's nice. I do like the simplicity of the number, 1. Or x is, let's see what I get when I plug in a minus. Ooh, thank you for doing that for me. That saves me some trouble. Negative 186. Well, that is not applicable because I'm making 0 or more t-shirts. So that one's out. And I have my 1 here. Let's write that over here where my answer should go. X equal to 1, meaning make 1 t-shirt. That does not seem worth it. But this analysis says, according to all the information, if I make 1 t-shirt, I'll at least I won't lose money. I might lose my time, but I'm not going to lose any money. All right, so it's a nice variation, mix things up a little bit, see something different, see something in words, you know, it's good, mix things up. But I'm not going to worry about too much variety in our applications at this stage because we don't have a lot of things that, or not things, that's a vague term. We don't have a lot of tools to allow us to handle complexity at this stage. But now that we saw how the problem is handled, let's see if we can squeeze in number 2, and there are a few more that you are welcome to try on your own. So let's have a look at number 2. Almost exactly the same, except the functions that are given are just a little different. So the cost in dollars to produce X bottles of something, I don't even care what it is, Sasquatch tonic, that's cool, is C is my cost function, just a different function, still the cost. And the price demand function, that predicts my price per bottle, is 35 minus X. Do everything you just did with these functions. So my profit function equals my revenue, which is little p times X, the price per item times the number of items, minus the cost. And the price first is 35 minus X. So 35 minus X, and it's hard to know how the price and the cost, how they're going to sort of interact with each other to see where the optimal situation is for me. That's why I do this analysis. I have to look at the function, and that then tells me. But I have to simplify the function first. What is the cost? Cost 10x plus 100. Remembering the brackets, 10x plus 100. All right. Simplifying this, I get 35x minus x squared minus 10x minus 100. One more step for my profit function. Negative x squared plus 25x minus 100. All right. Now again, I see some properties. A is -1, negative, meaning, as I would hope, I have a parabola pointing down, resulting in a maximum point, which is now the vertex I want to find. That vertex sits on the axis of symmetry, which is when x is equal to -b over 2a in general. In this case, it is -25 over 2 times -1. Oh, that's not so bad, 2 negatives, though it doesn't look very nice here. Let me fix this. 2 negatives, so it's 12.5, 12.5. Now we'll summarize this in a second. Let us just find the maximum function value, which is the y-coordinate of that vertex. Maximum function value is then the function when I plug in 12.5. Let's see if MathBot is interested in helping me, but please confirm what I'm getting here. Make sure you can calculate these things as well, right? Or try some MathBot action, get your own calculator, do whatever you want to do, but you have to be able to do it. So we'll do a negative 12.5 squared plus 25 times 12.5 minus 100. MathBot says, and I hope it's correct, 56.25. So to get, now let's say it like this, the maximum profit is, again, these are very small numbers. Oh, who cares? 56.25 when we, or they, or whatever, produce 12.5 bottles. Now, of course, now you can decide, okay, 12 or 13. We're just doing the analysis, forgetting the practical aspect of it. Of course, you have to round these numbers because you can't sell half a bottle. Maybe you can, depends. So that was the first part, profit function, number of items, maximum profit. What is the price that would go with it? or let's say then, the price per item is, well, my little p is the price depending on the items. That was 35 minus x over here. So 35 minus x is simple enough. Little p at 12.5, 35 minus 12.5 would be the price. Just, it doesn't matter how simple the function is, right? It's whatever the function says it should be. It's not 35 items minus 12 items. It's just a calculation that comes from somewhere we're not seeing. So what do we get here? 22.5. In other words, $22.50 per item. Oops, that's an ugly M. Item. All right. So far, so good. The last thing we want to do is the break-even point. Do I have more space this time? Oh, much more space, yes. We are going to break even when my revenue equals my cost, or the profit equals 0. My revenue was the price, 35 minus x times x. Cost was, I do not remember, 10x plus 100. 10x plus 100. So we have 35x minus x squared equals 10x plus 100. Now you can move everything to either side. It really doesn't matter. Let's move everything to the right this time. And then flip it all around. X squared, I'm moving everything to the right. So that means the 35 needs to go to the other side and become negative 25x. And then my plus 100 equals 0. Doesn't really matter which side. I kind of like the one that doesn't have a negative in front of the x squared, but it really doesn't matter. So that gets us into quadratic function territory, which we all know. No, quadratic function. Silly. Quadratic formula. We all know the quadratic formula. Can't forget it even if we try. You can try and forget it, but it will not work. So I have negative b, which is negative 25, which of course you can simplify on the fly. I just want to show it clearly here. B squared is still 25 squared, because the negative will just cancel anyway. Minus 4 times a is 1 times c is 100. Please, for the love of all things, close that square root so we see what's inside and what's outside, over 2 times a, which is 1. Now let's see perhaps what's inside the square root. Why not? 25 squared minus 400, I can just do right away. It is 225 indeed. So I have 25 plus or minus square root of 225 over 2. So x is equal to what I get when I plus and what I get when I minus. Two options. When I look at the function or the equation outside of the practical context, there could be negative numbers here, whatever answer. I then have to see, okay, which one makes sense when I look at the practical problem. So we'll just do them both. 25 plus square root 225 divided by 2. Hopefully someone can confirm the 20 that I get, or I'm going to let you do the minus one. Oh, you already did it. I didn't even ask. You're so efficient. 5. Very nice. Now in this case, did they give me any restrictions? X range is 0 to 35. So they're actually both. Strangely enough, sometimes it's hard to get an intuition for these things if you never really work with them, that both uh, amounts will give me a 0 profit. And it's because I sort of have a situation, oh, that's not a good line, that there's my X and there's my profit. And of course, there's a 0 profit. It sort of sits balanced around the maximum of 12.5, the 20, and the 5. So it's 7.5 on either side. So if I make 5 items, if I make 20 items, I'm still going to get a profit of 0. You want to get that middle sweet spot of 12.5 bottles. Of course, you're going to have to go 1 to a little bit on either side, either to 12 or 13. But because of the symmetry, it's going to be the same. So let's just exactly see what they want. Find and interpret the break-even points. Okay. Oopsie. Ooh, just enough space. Let's say like this: a profit of 0 results when we sell 20 or 5 items. There we go. Or a similar sentence. Hopefully you get the idea. Right, are there any questions? As we wrap up this little subtopic and slowly move to be done with our review topics. The upcoming topics will have some review and some new things, or maybe a new way of looking at it at the very least. Let me just open the schedule and see where we're at. Let's see here. We are on Wednesday here. Tomorrow you have the video that will be in the playlist. I'll put everything in the playlist right now. You have a video to watch, the self-paced. Pause it, think about it. Don't rush. Don't feel rushed in real time. But it's equally important, where we just add another function, mainly the square root function, and check its transformation. Some tricky things there sometimes. And then we're moving on to polynomials, building on polynomials into limits. And we might, as we go into next week, start doing things you haven't seen before. So please adjust your studying appropriately. Question here, just to confirm, now we should be able to do everything in problem book 1.8. Let's actually look at the problem book. So of course 1.7 is good to go. They're shuffled around a little bit. Yeah, we've done all the transformations, especially 1.8, which is not dependent on a function. Definitely do them. They're really good. People are sometimes too attached to the function itself, and they don't really see the transformations. So all of 1.8 for sure is good. And 1.9 here you see still transformations, but we have the square root function and some higher degree polynomials and things. So we'll start working on 1.9 tomorrow and the day after. And then 1.10 is just another spin on that same thing. So wait for tomorrow. Just doing it more in words, the transformations, and then next week for 11 and so on. As always, some people do email me with their questions. It's good. Get feedback. Keep up to date um, as we go. And if things get a little bit tough for you when they happen, just put some more effort in so you don't fall behind. That's the most important thing. So I won't see you tomorrow. Enjoy the video, I guess, that you can watch whenever you want. But don't skip it. Do get to it at least before next week. Just want to see someone's typing here. Oh, thank you as well. Until, I guess, Friday then.